Chlorine.
If now I put hydrogen plus 1, oxygen minus 2, can you guess for chlorine?
Will it be +1?
Why? How come chlorine became plus? This was the point where chemistry developed another thing, and normally later it became a joke. In a low level style, we say that in chemistry everything is relative, and when you are teaching in a class, a big class, especially when a lot of students are there, so it becomes a joke. Their students say, sir, you told something last year and now you are saying no, this is not like that. You told. So this is very interesting in chemistry, that in chemistry everything you study is actually relative. Everything is relative. Whatever we study, acid behavior, alkali behavior, oxidizing agent, reducing agent, valency, oxidation state, they all are actually relative in nature. This is a good example of that, that hydrogen and chlorine was negative, but in presence of oxygen, chlorine is behaving plus. Why chlorine is behaving plus? After the development of electrochemistry, the chapter we are doing now, they solved this mystery. They concluded that every element is actually has a competition behavior. Chlorine definitely wants to have a negative charge. In O level, we studied why chlorine is happy to get a negative charge, because there are 7 electrons in the outermost shell. So chlorine will be happy to gain one more and become an octet. But now chemistry has concluded that it is now dependent on the neighbor element. It is dependent on the neighbor element, that how much it will be allowing for the positive or negative behavior. Hydrogen is a famous electropositive element. Now, look at this compound, sodium hydride. Sodium is +1. So now guess what hydrogen will take?
-1.
Logically, at O level, this doesn't make any sense, because hydrogen cannot lose. Hydrogen should not gain one electron, because it has a tendency to lose one and become stable proton. But now, what is the final concept? The concept is there that the ability to gain electron or the ability to lose electron is relative, whom you are going to make a bond. For example, when you make a compound NaCl, sodium is +1, chlorine is -1. But when you make NaClO3, then you will find an interesting issue, that chlorine will take +5. It means we have reached our fifth concept. After the discovery of this redox potential, they concluded that it's a neighbor. It's your neighbor. It's your neighbor element who will decide what behavior you will adopt. Iodine is a famous halogen, and halogens should be electronegative. But iodine is found in many places like a metal. So we have a concept. It depends upon the neighbor element what behavior it will take. Will it be happy to lose electron, or will it be happy to gain electron? Fluorine is the most electronegative element known. So whatever comes with fluorine, it has to become positive, no matter what it is. Even oxygen comes. Even if oxygen comes here, fluorine will tell it to become positive. Why? Because fluorine is the most electronegative. It's a very funny example. It's a very funny example that if you have a person in your class who is the worst in performance, in class marks, then whoever sits with him will be a better student.
Yes.
Am I right?
Yes.
The duffer, I shouldn't use the word duffer, but let's see the weakest candidate. the person who has the lowest marks. This is how our Cambridge system also works. This is what we say, a comparison, relative. So now we made the concept. So I have two concepts now, which are I'm putting now again. The first concept says that after the discovery of hydrogen potential, they tried different metals with hydrogen, and they concluded that some metals are able to form a positive potential with hydrogen. Some metals have a ability to form negative potential with hydrogen. So it's actually hydrogen became a foot mark, above zero and below zero. Second concept is that this oxidizing or reducing power is relative. Whom you are sitting with, oxygen sitting with hydrogen will be positive, oxygen sitting with will be negative, and hydrogen sitting with fluorine has to be positive. So we made these two concepts, and you have already copied it. So this was the foundation position where scientists concluded that it's all relative. The behavior of oxidation, the behavior of reduction is not absolute. It is also relative. Now, I had explained you this concept in my last class, that what they were making cells. Now we use cells so commonly that this doesn't look to be a topic, but it was a topic at that time. Cell is a portable supply of electricity. Combination of cells is called a battery. When we show the movement of electrons, it's a physics concept. When we show the movement of electrons, the direction of current is opposite. It's a convention. The direction of current is opposite to the direction of electrons. Now you have to write under it after copying this one. After copying this one, you can write under it that this shows.
Okay.
This shows that hydrogen became a reference position for all potentials. This shows that hydrogen became the reference position for all potentials.
Okay.
Now write under it, the combination of two half cells generates current. Combination of two half cells
Okay.
Next line. Combination of cells is called a battery.
Okay.
These additional points are obviously because you have not done physics and you have to patch up this. These are very small concepts and you will very quickly capture them. And also, when you next time use electrical circuits, whenever you next time connect a circuit like a 2-pin plug, so you have to especially look at the shape. There are 2 pins. one for the live wire at normally 110 volt, second at the 0 volt. So this makes a pair. Circuit works in that way that one is at high potential and second is at 0 potential. It is just like a slope. If you leave something like a car on a slope without a brake, the car will eventually come down. So you have to now look at this screen. You have to copy this.
Okay. Copy.
Now give a new heading, the electrochemical series.
Okay.
Electrochemical series. Electrochemical series is actually something we know already. This is again the Cambridge syllabus is sometimes a bit twisted. They have taught us reactivity series in O level, and majority people learn it by heart. It was needed there. Now how this series was developed, now we are discussing that how they made this series, that which element is more reactive than what other element. Behind that series, there was a concept of hydrogen half cell. The plan was there that keep this hydrogen cell fixed and start changing them, putting different metals one by one and making the scale. It is just like the case in chemistry that you kept carbon 12 fixed and keep on comparing elements with other elements with carbon. So they were getting the mass of other elements. It's a pure comparison game. It is a pure comparison game. So it is fixed. Hydrogen half cell is fixed. We are changing, sorry, we are changing the elements. Now, what they did, they start putting different elements with hydrogen. They found their hydrogen half cell, and then they develop a list. That list is called electrochemical series. This list of elements and ions showing their relative reactivity and oxidizing or reducing power. Okay. Now, after giving the heading, right under it, keeping standard hydrogen half cell fixed, keeping standard hydrogen half cell fixed, keeping standard hydrogen half cell fixed, different elements were tried, different elements were tried
Yes.
For every pair like this, for every pair, the potential is recorded from the voltmeter. For every pair, the potential was recorded from the voltmeter. The data is then arranged. The data is then arranged, and this is called electrochemical series.
Okay.
So now change the line and write under it in a bracket the well-known, write under it the well-known reactivity series was also a product of this. The well-known reactivity series was also a product of it. Bracket close. So reactivity series you already have studied in O level. I had posted again today, and that's a good series. But in A level, you can't refer to it like you used to refer it in O level. Why this element cannot replace this? Why lithium can replace sodium, or sodium can replace this? Why chlorine can? Why chlorine can replace bromine, but bromine cannot replace chlorine? You could refer to reactivity series, but here I have given this point in a bracket. It means in A level, you can't refer to reactivity series. It's only for our own knowledge. Now, we have to see how we define this series. It's a list of elements and ions showing their, focus on this word, showing their relative reactivity and oxidizing or reducing power. As already mentioned, that chemistry is actually a type of relative measurement, starting from chemistry first table, the periodic table. Definitely the chemistry first table, the famous periodic table, is also relative. Why it is relative? Because we call it relative atomic mass, relative molecular mass. So chemistry somehow is full of relative measurement. That is why in chemistry results sharply vary if you do the experiment in another lab in some other conditions. Now you have to copy this screen.
I've copied.
All equations are written as reduction, because you know that reduction and oxidation are opposite to each other. So they had to make a choice. Either they could write equations in reducing style or oxidation. So they took reduction as a convention. A species with a higher E5 value oxidize reverse one with a lower value. Now this is called reactivity series. This is called electrochemical series. You can look at it. You can see the top. the top member is, as expected, fluorine. Why fluorine is there on the top? Fluorine is the most electronegative element known. In our simple terms, fluorine can snatch electrons from anyone in this reverse model. The value is plus 2.87, the most electronegative element. It always wants to become negative. So it is the most negative personality in our chemistry. So no one can be more negative than fluorine. Then comes MnO4. You must identify that it is actually KMnO4. K is cancelled out as a spectator ion. Number 3 is chlorine. Number 3 is chlorine. It's a good electronegative element, but less than fluorine. Then Cr2O7, famous actually K2Cr2O7. And then the list continues downward. I have shared this. I have shared these pages with you today. There are 2 pages of this, and this list actually shows how electrode potential help to arrange the elements. And these are all reduction equations. You can see electrons are being gained. When you go below 0, look at this position. Look at this position.
Yes.
Hydrogen. Look at this position, hydrogen. And it is at 0. When you go below 0, the potential is negative. Potential is negative, and then you can check further. An equation with higher E5 value will reverse an equation with a lower value. It means in this case, chlorine can replace iodine from a solution. Chlorine is more electronegative than iodine.
Yes.
Call you a famous equation from O-level chemistry. I hope if you can recall it.
Yes.
Chlorine plus potassium iodide. And if you remember, potassium iodide is a reducing agent and chlorine can replace it, which shows that chlorine can do that. Why? Because chlorine is more electronegative than iodine. And these are the reactions. Chlorine is a more powerful oxidizing agent. It has a higher E5. So if you see the half equations and you combine them, as we used to combine, somehow we used to combine earlier also, the 2 electrons, if we add these 2 equations, the 2 electrons cancel and we get this equation. So we come back to our summary. If species are arranged in order of their standard electrode potential, you get a series that shows how good each substance is gaining electron. All equations are written as reduction process. A species with a higher E5 oxidize reverses one with a lower value. So you have to copy this block, the last block which I have made it. You have to copy this one.
Okay. I've copied.
Now look at this value game, and I have highlighted these 2 equations. You have copied this. Okay, you have copied this. So now you are supposed to look at this screen here. That these are the 2 equations, and you have to see that chlorine is more powerful oxidizing agent. It has a higher E5. But here you have to give the reference of the reactivity series. I have given you the PDF and it's also in the syllabus. So after copying this, write under it, refer to the PDF on electrochemical series. Like periodic table, it's a reference sheet. Refer to the PDF on electrochemical series. Now, you have given the reference. Now you have to copy these two equations which are being in our observation presently, these two equations only.
Okay. Okay, I've copied.
The rule is very interesting. The rule is to remember that the more E5 value will reverse the less E5 value. So you can now notice here that iodine equation, has it been reversed? Look at the iodine equation. So have we reversed it?
Yes.
So this is the concept of reversal. Now you have to copy this screen.
I've copied.
The lower the standard potential value, the higher the reducing ability of a particular half cell, and vice versa. A higher standard reduction potential value denotes greater oxidizing ability of a half cell. The lower the standard potential value, the higher the... If we place a piece of iron in a dilute solution of copper 2 chloride, the iron surface soon becomes covered by a layer of metallic copper, while the solution develops a yellow color. Iron replaces copper in the solution, which indicates that iron is more reactive than copper. If we now place a piece of silver in a dilute solution of copper chloride, despite prolonged observation, no changes can be seen and the solution remains clear. If any silver 1 chloride had formed, it would be visible in the form of a white precipitate. This time, the metal was not displaced from the solution because silver is less reactive than copper. Reactions of this type can be predicted on the basis of the position of the metals involved in the electromotive series of metals. Starting from the top of the electromotive series, each metal, under standard conditions, reduces the metals that are placed below it in the electromotive series. That is, it displaces them from solution, while itself being displaced by the metals above it in the series. For example, metallic copper can reduce ions of silver, mercury, platinum and gold, but does not react with ions of magnesium, aluminium or lead. This conclusion can be summarized by the statement, low reduces high, high oxidizes low. If we place a piece of iron in a dilute solution,
now this animation is very interesting, and this is where you can see how chemistry is important, and that is why gold in jewelries is so much famous. Gold doesn't rust. Normal conditions, gold doesn't rust out, and even silver stays for centuries. But iron, iron rust rapidly. So this was a very good understanding that actually it's a reactivity series position. So after making this reactivity series, they were able to control all the metallurgy, all the metals they were able to control.
metals characterized by positive values of standard reduction potential, such as copper, silver, gold, or platinum, do not dissolve in dilute inorganic acids. However, they can be dissolved using concentrated acids that have oxidizing properties. One of the products formed by the reaction is the appropriate non-metal oxide rather than hydrogen. Copper and silver react with concentrated nitric 5 acid according to the following equation. One of the reaction products is brown nitrogen 4 oxide. Copper also reacts slowly with concentrated sulfuric acid. Gold and platinum do not dissolve in concentrated nitric acid, which is why they are described as noble metals. Nevertheless, gold reacts with the mixture of 3 volumes of concentrated hydrochloric acid and 1 volume of nitric acid, known as aqua regia. The reaction yields a complex compound in which gold occurs in an oxidation state of 3. Metals characterized by positive
This is a very nice animation to understand that when you look at this reaction, the magnesium ions are in the electrode. Now you can see what's happening with magnesium ion. Look at zinc ion is coming. Zinc ion is coming up and it reaches the electrode. It now touches that, and look what happens. Zinc is there and magnesium is gone. How it is possible? Why zinc is there and magnesium is leaving? It means magnesium has replaced zinc from the solution. How come magnesium can replace zinc? It means that it is a game of reactivity. Who is more reactive than the other? Now these are the same ions. So logically, if they are same ions, they will not dissolve, and this would actually lead to a very interesting method of protecting important metals which have a tendency to dissolve. If you want to keep them safe and you want them not to rust, you have to keep them with their metal matching, the same ions in the solution if they are low in the reactivity series. These are hydrogen ions. They are coming from an acid solution. Hydrogen ions are there. and they are gaining, look, they are reaching the zinc atom. And when they reach the zinc atom, they take an electron from the zinc and they become hydrogen, and zinc, after losing an electron, become Zn plus 2. So zinc has to leave the solution. Hydrogen will convert into H2 as a gas. It will be released from the reaction. Now you have to give a heading, electrochemical cells.
Okay.
We have made this concept. Cell is basically, after the discovery of electrochemical series, they were able to well dictate the metals. They were able to well control the metals. They were in a position to predict who will displace whom. That is why now the structural engineers are able to form bridges even in ocean water. Even though ocean water is full of salt, every big number of ions are there, but no rusting, no corrosion occurs. So electrochemical cells are actually a product of it. That cells contain 2 electrodes, each electrode now having its half reaction. The electrons produced by one half cell are available for the other. Oxidation occurs at the anode, reduction occurs at the cathode. When we started the class today, I had given you a concept that in order to determine the potential of an element, we were joining it with hydrogen half cell. Hydrogen was 0, so we were finding zinc, copper, their potential. After that, they made a reactivity series. Then they thought, why don't we combine metals together? Now, leave hydrogen, we have the values now. For example, a pair got internationally famous, and that was the pair of copper and zinc. That was the first cell in our knowledge. So this is how an electrochemical cell works. You have to, after giving the heading, you have to copy this screen.
Okay. I just wanted to ask, we can't say that the electrochemical series and the reactivity series are the same, right?
No. You can say that electrochemical series is a source, and the reactivity series of our O level, it's a baby version of it. It's a reduced version of it. Definitely, reactivity series of our O level was derived from here. But after we reach here, now you can't refer to it. You can use it yourself in your head, but you can't write in the paper that according to reactivity series. You have to refer to electrochemical series. They are not the same, obviously. because in reactivity series, if you remember, we were mainly covering metals, and here we have everything. If you look at this series carefully, they have a world of elements, compounds, and look at here, fluorine, MnO4, chlorine, Cr2O7. Virtually, if you look at the PDF I have sent you, there are 2 pages in it. Virtually, they actually covered all important species. And while if I have also shared with you reactivity series of our O level. Now we made the concept of cell. Now let it put again from the physics background. What is a cell? When you put a cell in your remote control or anything else, cell is a portable source of DC. So right under it, cell is a portable source of DC.
Okay.
What is DC? DC means direct current. So remember this concept, cell is a portable source of DC. Now this is very important. I mentioned last time also that in A2 physics, A2 chemistry, and a camera system, many concepts cannot be understood well until you know their history. Just like you're studying a topic which is regarding to cells. Cells are commonly available in our life, but this was the time when the first cell was going to be made. There was no portable source of electricity at that time. If you understand that, then you will understand what is the topic, what the topic was doing. It was going to make the first cell ever. Now, for example, consider the cell made of copper and zinc. This is their most famous cell, most famous pair. So now you have to copy this screen.
I've copied.
Now, anode will, zinc will become the anode, and cathode, copper will become the anode. If you, cathode, copper will become the cathode. If you look at the diagram, you will see that zinc is going to lose electron and copper is going to gain electron. How we know that? After the electrochemical series. Just like here in this example, here. In this example, chlorine is losing electron and iodine, chlorine is gaining electron and iodine is losing electron. How we know that? We know it from the reactivity electrochemical series. So it means onward, all decisions are being made on the basis of reactivity electrochemical series. Now, look at this. You have to copy now this screen.
Okay. I've copied.
Look at this screen. This is called electrochemical cell. If you look carefully, you will see that copper electrode is thinning out, while zinc electrode is getting healthy. This is called salt bridge. It's a compensation of ions. It is a compensation of ions to balance the transfer of electrons. This is called salt bridge. The green color circles are electrons. The green color circles are electrons. The capital G means galvanometer. It's a very sensitive meter used to measure electric current. I repeat for my last concept for today. An electrochemical cell consists of two half cells, none of them hydrogen now. Two half cells, one half cell will be losing electron and one half cell will be gaining electron. Then why salt bridge? Salt bridge is to transfer the charges. The salt bridge is to transfer the charges so that the concentration of solution does not change and remain constant. So we keep it up to here, and we will do it inshallah in our next class. Thank you. Bye. Allah Hafiz.